All right, in this video, I'm going to give you the most complete explanation for the cast rule and pretty much all the different cases you can kind of see for this problem. So let's get started. With the cast rule, we use it to solve trigonometric problems, and I'm going to do a lot of problems in this video, but let me just explain the cast rule first. The cast rule is a set of axes. It starts with a C in the bottom over here, bottom right, and above it is an A, above it is over here is S, and then we have a T over here. So what do these letters stand for? Well, C stands for cos is positive. A stands for all are positive. S stands for sine is positive. And T stands for tan is positive. Basically, in the first quadrant right here, all my ratios are positive, and I'm going to explain what ratios are in a bit. In my second quadrant here, the only ratio that's positive is sine. In my third quadrant here, my only ratio that's positive is tan, which means in the third quadrant, sine and cos are both negative. And in my fourth quadrant over here, only ratio that's positive is cos. The other important thing to understand is that this over here is 0, this over here is 90, this over here is 180, this over here is 270, and then one full circle is 360 degrees. So let's say I start over here. I'm basically at 0 degrees. I go in the counterclockwise direction. Eventually I'll hit like 45 degrees at some point. And then once I hit a full right angle here, that's 90 degrees. Then I go from 90 all the way to 180, 270, then 360, which is one full circle. So we can have ratios in each of these four quadrants. My ratio in this quadrant over here is just going to be whatever the angle, the acute angle is. So the acute angles are called beta. Okay, so let's say, for example, I'll do some separate diagram here. And then after this diagram, I'll explain this with a bunch of problems. So I can either be on these lines over here, which are 0, 90, 180, 270, 360, or I can be between the lines. So if I'm between the lines, I can be in any one of the four quadrants. Now this tiny angle over here, no matter what quadrant you're in, is called the related acute angle. Again, it's an acute angle because it's less than 90 degrees. It's represented by the sign beta. If I want to go from here to here, I'm going to find my principal angle. So let's say my solution is in the first quadrant. I'm going from here to here, which is beta. And my principal angle is going to be theta, which is going to be the exact same as beta. So my principal angle is theta. And principal angles are the solutions to all these questions. If I'm in the second quadrant, over here, here's my tiny angle, my acute angle called beta. My principal angle, remember, your principal angle always starts over here and ends at your line. So if I want to go from here to here and I want to figure out how much this is, I know from here till here, it's 180 degrees, but then I'm going back a bit by beta. So my principal angle theta is 180 minus beta. If I'm in the third quadrant, right there, my acute angle is beta. My principal angle, I want to go from here all the way till this line here. So I know that half a circle is 180. Then I'm going a bit extra. Means that my principal angle is 180 plus beta. And then if I'm in the last quadrant over here, if I'm in the last quadrant, my acute angle beta is right there. And I'm going to go all the way around over here till there for my theta. So I know that a full circle is 360 degrees. And then I'm going back by a little to get the line. So 360 minus beta. So to summarize all this, if I'm in the first quadrant, theta is just the same as beta. If I'm in the second quadrant, theta is 180 minus beta. If I'm in the third quadrant, theta is 180 plus beta. And if I'm in the fourth and final quadrant, theta is 360 minus beta. So these are all of the rules of cast rule between 0 and 360 degrees. And for all the questions, I'm going to be talking about between 0 and 360 degrees. I'm going to keep it a little bit basic. I know at this point right now, nothing at all makes sense, and that's perfectly fine. Nothing should make sense at this point if this is the first time you're looking at this topic. All of this should look like it should have no meaning at all. But now we're going to go on to the examples. And when I show you the examples and complete the examples, all of this, what I've explained here, is going to make 100% sense to you. I guarantee you that, as long as you follow with the examples. And I'm going to show you the examples that cover everything. Okay, so we use, like I said at the start of the video, we use the cast rule to solve trigonometric equations. So what is a trigonometric equation? Again, remember all the questions I'm doing right now are between 0 and 360 degrees. So let's start with the first question over here. I'm going to start with sine theta equals to 0.5, for example. I'm also going to stick with a calculator for this video. Make sure your calculator is in degree mode because we're working in degrees. And I'm not going to explain anything to do with special triangles or the unit circle, because it is possible to do a bunch of these questions without the calculator. But again, I'm explaining all of these using a calculator. So this is all applicable to basically a calculator test. However, it can be applicable to a non-calculator test as well if you use the same rules with special triangles. So here's the question right there. Sine theta equals to 0.5. Basically, you're given a ratio and you're trying to find an angle. That's when you use the cast rule. The number on the right side is always called the ratio. And theta is the angle. So starting from my cast rule, I know that sine is positive in the first and the second quadrant because all are positive here and sine is positive here. In this question right over here, my ratio is positive. So when I do my cast rule, I know that sine is positive in the first quadrant and sine is positive in the second quadrant. Now that I have my two quadrants, I need to find my acute angles next. In order to find the acute angle, all you have to do is isolate theta. So do the sine inverse of 0.5, and you can do that in your calculator. Sine inverse of 0.5 is just 30 degrees. So my two acute angles are 30 degrees. Now I just have to find my principal angles using the little rule that I gave you at the end over here. So in my first quadrant, theta is the same as beta. Second quadrant, theta is 180 minus beta. So in my solution here, my first principal angle is just 30 degrees. And my second principal angle over here is 180 minus 30, which is 150 degrees. So my two solutions for this question are 30 degrees and 150 degrees. All this means is that in a calculator, if you type sine 30, you'll get 0.5 or 1 over 2, which is the ratio we have in this question. If I type sine 150, again, I'll get 1 over 2 or 0.5, which is the ratio in this question. And all we're doing is, if we're given a ratio, we are finding all possible angles between 0 and 360. That's what the CAST rule is for. Now that I've done the first example, I'm going to go through the rest of them really quick. I'm going to cover every single example you need to know for CAST rule so that you can perfect this concept. And all the questions are going to go in order, and all of them are extremely important. Second question here, sine theta equals negative 0.5. As we can see, this one is very similar to the first one. I'll start by doing my CAST rule. In this question, my ratio is negative. So if sine is positive in the first two quadrants, it means sine is negative in the final two quadrants. Okay, opposite of positive are negative. I'll do the sine inverse of positive 0.5. Do not include the negatives to find your acute angle. And guess what? If I put this in my calculator, I'll get the exact same answer. The acute angles are both going to be 30 degrees because there's no difference in these two cases other than the negative. And then now my solutions are in the third and fourth quadrant. If you remember from that rule earlier, I'm not going to show that paper again. I'm in the third quadrant, theta equals to 180 plus beta, which is 210 degrees. And in the fourth quadrant, theta is 360 minus beta, which is going to be 330 degrees. So my two solutions for the second question are 210 and 330. I've explained sine over there. I'm going to go to cos next. I'll do these quicker now because I think you're going to start to get the idea of what's going on. Let's say I had cos theta equals to 0.5. I'm going to start with my CAST rule. Cos is positive in the first and the fourth quadrant in A and C. Because all are positive, cos is positive. To find the acute angle, I'll do the cos inverse of 0.5, which is 60 degrees. And then my two solutions are theta equals to 60 degrees in the first quadrant and theta equals to 360 minus 60 degrees, which is 300 degrees in the final quadrant. Let's go to the fourth example. Like I said, I'm going to go through these a bit quick now because, like I said, you're going to start to get the idea, but you want to cover the entire concept. Next question, cos theta equals to negative 0.5. You probably already know how to do this one with all the explanations that I've given, so I'm going to cover it pretty quick. We have cos and we have a negative ratio. If cos is positive in these two, cos is negative in these two over here. For the acute angle, I'll do the cos inverse of 0.5, which will again give me 60 degrees. And then my first solution right here is 180 minus 60 in the second quadrant, which is 120 degrees. And over here, it's 180 plus 60, which is 240 degrees. So my two solutions to these questions are 120 and 240 degrees. Let's go to the final ratio of tan, which again I'll cover pretty quickly because it's simple. So if I'm doing this, tan theta equals to 0.5. I'll use the same number for these first couple of examples. So again, I'll start with my cast rule for this one. Tan, the ratio is positive. Tan is positive in the first and the third quadrant in A and T. Find the acute angle. I'll do tan inverse of 0.5 in my calculator. I'm going to round this to a whole number. It's a decimal, and most answers will be decimals, but you can round to a whole number. If I round to a whole number, I'll get my acute angle to be 27 degrees. Then my two solutions are 27 degrees and then 180 plus 27, which is 207 degrees. And then last simple or basic example, but there's going to be quite a few more exception cases that I'm going to explain after this, is a negative ratio for tan. I'll use the same number. So tan is negative in the second and the fourth quadrant. Acute angle will be the same, 27 degrees. And then my two solutions are 180 minus 27 is 153 degrees. And 360 minus 27, which is 333 degrees. So now that you understand the basics of the cast rule, hopefully by this point you understand the basics of it. I know I've gone through a couple examples pretty quick, but I think you should have a general idea of how this works. I'm going to explain all the possible exceptions to this rule and why these exceptions happen. So let's start with the first exception. Let's start with sine theta equals to 1.5. I'm going to follow the exact same procedure that I did earlier, okay? So if I do my cast rule, sine is positive in the first and second quadrant. And if I do the sine inverse of 1.5 in my calculator, I'll get math error. It means there's actually no solution here. So why does this happen? Well, let's think about this logically. You may have never seen a sine graph before, but I'm going to draw a sine graph for you between 0 and 360 degrees. A sine graph starts on the axis, goes up to the maximum, comes down to the minimum, and then it repeats forever. But like I said, I'm only going to draw it between 0 and 360 degrees. If that's 360, this is 180. The maximum over here is at 90 degrees, and the minimum over here is at 270 degrees. The maximum y value is positive 1 up here, and the minimum y value is negative 1. So let's think about all the sine questions we've done up till now. Basically, the first two examples that I showed you right over here. Okay, I'm going to explain them through the graph. So the first example we had was sine theta equals 0.5. 0.5 is approximately over here, halfway between 1 and 0. If I draw a dotted line across, there are two places where it intersects the graph. These two places are the solutions that I found, which were 30 degrees and 150 degrees. So this one right here is 30 degrees, and this one is 150 degrees. So all you can see is we are using the cast rule to find the x values, which are basically angles, given a y value, which is a ratio. In the second example, I had sine theta as a negative 0.5. Negative 0.5 is down here between a negative 1 and 0. I draw a dotted line across. Again, I have two solutions. And if I look at the x values of these two solutions, they're basically the two answers here, which are 210 and 330 degrees. So I hope you're understanding the cast rule now. So in this final example over here, where I had sine theta equals to 1.5, it didn't work because there's no value of theta where y is 1.5. Y is only between -1 and +1, which means your ratio has to be between -1 and +1. If you have anything above +1, like I did here, or anything below -1, you can automatically say no solution. I'll give you another example. If I have cos theta equals to -1.8. Again, I can instantly state no solution because similar to a sine graph, a cos graph alternates between +1 and -1. This is a cos graph between 0 and 360, similar to a sine graph, but it's just slightly shifted. So for sine and cos, your ratios have to be between -1 and +1. Otherwise, there's no solution to the question. For tan, however, you can pretty much have any value possible. For example, if I do tan theta, the third exception, tan theta equals to 1.8. Well, let's do this with our cast rule, and then I'll explain it through the graph after. Tan is positive in the first and the third quadrant. In my calculator, if I do tan inverse of 1.8, I'll get 61 degrees as my acute angle. Then my first solution is just 61 degrees. My second solution is 180 minus 61, which is 119 degrees. So for tan, you can actually have any value. There are no restrictions. The reason why is a tan graph looks like this between 0 and 360, goes up forever. You have something called an asymptote, which I won't really explain now. Then it goes like this again, another asymptote. Then it goes like that, and then it keeps repeating forever. But like I said, I'm only going to draw between 0 and 360. So for tan, you can go all the way till a million, a billion, a trillion, because this goes up forever. So for tan, you can have any value. There's no restrictions. You'll always get a solution. For sine and cos, you need to be between +1 and -1. So now you've learned about the first type of exception, which are restrictions on your ratios. Let's go to the final type of exceptions. The 7 examples in this question, 3 for sine, 3 for cos, and 1 for tan. So the fourth exception here is sine theta equals to 1. Now, sine theta equals to 1, sine theta equals to 0, which is the fifth one, and the sixth one is sine theta equals to -1. These three will never work using the cast rule. If you try the cast rule for these, you will not get the complete solutions, and I'm going to explain these through the graphs we have. For sine, and I drew this graph a bit earlier, but I'm going to draw it again. Sine graph looks like this. Whenever you have a sine, cos, or tan ratio between 0 and 360, we've always had two solutions, right? But if I look at a graph like this, for sine theta equals to 1, you only have one solution here. And this solution has an x value, I showed it earlier, of 90 degrees. You need to have this graph memorized for the exceptions if you really want to perfect this topic. So for sine theta equals to 1, we only have one solution, which is 90 degrees. For sine theta equals to 0, I have three solutions, 0, 180, and 360 degrees. And for sine theta equals to -1, I only have one solution over here, which is 270 degrees. So those are the three exceptions for sine. Guess what? We have another three for cos. And again, I'll draw my cos graph over here. Again, cast rule will not work on these. You won't get the complete solutions. This graph is not perfectly symmetrical, but I think you get the idea. 1, -1. So for cos theta equals to 1, I have two solutions, 0 and 360 degrees. For cos theta equals to 0, again, I have two solutions, which are 90 degrees and 270 degrees. For cos theta equals to -1, I only have one solution down here, which is 180 degrees. Last but not least, let's go to the final exception for tan, and that is tan theta equals to 0. Now you can look at the tan graph, which I did earlier. I showed the tan graph earlier. There's three solutions for tan theta equals to 0. Three solutions are 0, 180, and 360. But you can also remember it's the same as sine for this one. So that's an easy way to memorize it. Other than these 10 exceptions that I've shown here, or well, technically not 10 because tan is not an exception. It works with the cast rule. So the 9 exceptions that I showed here, where sine and cos are not between 0, not between -1 and +1, and then you have these 7 exceptions here. So if it's not between -1 and +1, sine and cos have no solutions. And these 7 exceptions for sine, cos, and tan have to be solved using the graph. Every other question you do will always use cast rule and will always have two solutions between 0 and 360 degrees. So that is a complete explanation of solving trig equations using the cast rule, and you can use what I've explained to you over here to solve any trig question between 0 and 360 degrees. And one other thing that I didn't mention is that we're always doing a k value of 1. So it's always sine theta, cos theta, tan theta. You don't have like things like sine 2 theta or cos 3 theta. Basically, the value here is 1 or does not exist. That's, again, something that I'm not going to cover in this video because that's a bit of harder questions, and I have other videos on that that you can watch to understand how those more complex problems work. If you made it to the end of this video, you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.